Hello and welcome back to the Blackboard on our final chapters, or final chapter. In this example, we're going to be skipping the steps of finding the eigenvalues and eigenvectors, and we're going to be confirming that the eigenvalue and corresponding vector is one of the matrix A that we are given. And so this is pretty much highlighting the idea that A of x is the same thing as lambda x. So we're just going to go ahead and get started with the first example. And so the first one is just verifying that A times x1, which is 1, 0, 0, -1, multiplied by 1, 0. Yes, we have to go back to matrix multiplication, but this one's a simple one, so this would simply just be 1, 0. And now we're going to do it with the lambda 1, x1, which is just 1 times 1, 0, which surprisingly, not really, gives you the same thing. So yes, the first eigenvalue and the first eigenvector is part of A, and so for the second one it's just the same thing, it's just a different one. So you have 1, 0, 0, -1 multiplied by 0, 1. And so this just means get everything from the second column. That's be 0, -1. And then to verify, or not to plug in the other one, lambda 2 x2 will just be equal to -1 multiplied by 0, 1. And yes, this also does give you 0, -1. So first example is pretty light one, it's relatively simple. So now we're going to move on with part B, which is a 3 by 3. So we have to check all three of them. And we are given the first one being 2, 0, 0, which I'm just copying A, 3, then 1, 2, 3. We're multiplying this by 1, 0, 0, which luckily means take everything from the first row, not row, column. So this would just be 2, 0, 0. And then to check with the other one, it will have lambda 1, x1, which is just 2 times 1, 0, 0, which also equals to 2, 0, 0. So the first one is an eigenvector eigenvalue. The second one, again, is the same thing. I am not going to copy the matrix A, just kind of have to drag it down. So we have to multiply it by 1, -1, 0. And so that will be equal to 1 times 2. Yeah, 1 times 2 is 2. Then -1 times 3 is -3, then 0. And then the other one we have 1 times 0, which is 0, -1 and 1. It's just 1 plus 0. Then the last one is 0. And so this will give you 2 minus 3 is equal to, what's 2 minus 3? -1. Then 1, 0. and then to check with the lambda 2, we will have lambda 2 x2, which is the same thing as -1 multiplied by 1, -1, 0. So the signs flip, so we have -1, 1, 0, which is the same thing as the other one. So yes, this one's also an eigenvalue eigenvector. And then finally, the last one, you're multiplying it with 512. And so this will give you 5 times 2 is 10, and then 1 times 3 is 3, so plus 3, then 1 times 2 is 2, so plus 2, and then the other one will just give us 5 times 0 is 0, 1 times -1 is -1, and then 2 times 2 is 4, so plus 4. And then last one is 0, 0, 2 times 3, which is just 6. And so adding these all together, we'll get 2 plus 3 is 5, plus 10 is 15. -1 plus 4 is 3, and then 6. Again, checking the third eigenvalue, the third eigenvector, we get 3 multiplied by 5, 1, 2, and that will give us 15, 3, 6. So yes, this one is also an eigenvalue with this corresponding eigenvector. So now we're going to do the last one, which it only has one eigenvalue with an eigenvector. So we don't have to do this 3 times. I believe if you do the work of this, you should be able to get that there's only one eigenvalue with a multiplicity of 3. And so to check, we are going to do the same thing. So we are going to multiply 0, 0, 1, or just matrix A, with the eigenvector 1, 1, 1. And so this will simply give us 1 times 0, 0, 1 times 0, 0, and then 1 times 1 is 1. And then 1 times 1 is 1. Then we have zeros on the others. And the other one is 0. Then 1 times 1 is 1. And then 0. And so now to check, we'll have the eigen 1 multiplied by x1, which is just 1 times 1, 1, 1, which is just 1, 1, 1. So these two are the same. That means that this eigenvector has its corresponding eigenvalue for this matrix. And that's pretty much it for this video. On the next video, we are actually going to go into the, I guess, the prequel of this, of actually finding these eigenvalues and eigenvectors. I might actually do the same. I might actually do these same examples and showing you how to actually find them for these. So we'll see. But other than that, that's pretty much it, and I'll see you guys in the next video.